So if firms with market power can choose their price, how do they decide what price to charge? Well, remember that all firms want to maximize their profits, meaning that they will maximize choosing quantity, total revenue minus total cost. And so what we end up with when we take the derivative and set it equal to 0 is the condition for profit maximization that marginal revenue should be equal to marginal cost. In competition, marginal revenue was just equal to price because price was constant. But here, price is no longer constant. The price that we charge is also related to the quantity that we sell because demand is no longer perfectly elastic like it was in perfect competition. Demand is downward sloping. Firms with market power face a downward sloping demand curve. So what does that mean in terms of profit maximization? Well, when we go to calculate marginal revenue, taking the derivative of total revenue with respect to quantity, we here have two functions of quantity multiplied, and we need to use the chain rule to take the derivative. So remember, the chain rule is first times the derivative of the second plus second times the derivative of the first. So first, price times the derivative of the second, it's just 1, plus the second, quantity, times the derivative of the first. And now here I've written this generically, but basically what we're doing is we're taking the derivative of price with respect to quantity. As I change the quantity I sell, how does that affect the price or vice versa? And that relationship between price and quantity is given by this downward sloping demand curve. Okay, that's the relationship between the price I can charge and the quantity that I will sell. So for linear demand, you'll remember from your intro class, if we assume a linear demand curve, A minus BQ, then my total revenue, price times quantity, would be A minus BQ times Q, or AQ minus BQ squared. And then taking the derivative would get me marginal revenue of A minus 2BQ. So for linear demand, my marginal revenue curve always started at the same intercept as the demand curve and had twice the slope. So it intersected the x-axis at half of demand's intercept. So you could see here if demand, right, generically as we've written it, started at A as the y-intercept and had an x-intercept of A over B, marginal revenue would also have an y-intercept of A and would have an x-intercept of A over 2B. So this is here our generic linear demand function, generic marginal revenue function. And we want to show then how marginal revenue is related to profit so that we can try to understand the relationship between profit maximization, marginal revenue, and elasticity. You'll see here that marginal revenue for my linear demand curve, it goes to 0 at the midpoint, halfway down the demand curve, the midpoint of the demand curve. And this point, you'll remember, is the particular point where the price elasticity of demand is equal to 1. It's unit elastic. And in intro, we had you memorize that that is the point that maximizes total revenue. Well, that's exactly the same thing as saying that this is where marginal revenue goes to zero, because marginal revenue is, of course, the slope of the total revenue curve. So up here, we have elastic demand. Down here, we had inelastic demand. And at this unit elastic point, marginal revenue goes to zero and total revenue is maximized. So let's just relate that to the graph of profit here, or total revenue. You know what? This should be total revenue, not profit, because I'm not talking here about cost at all. So what I have, if I am here, I'm selling 0, and I'm charging a really high price and selling nothing. So I'm going to get no revenue, right? Total revenue would be 0 because quantity is equal to 0. If I go to the other end of the demand curve, way over here, I'm selling a ton, right? I'm selling a lot, but I'm charging a price of 0. So again, down here at the other end of the demand curve, my total revenue, price times quantity, is going to be 0 because over here price is 0. And what's happening is my total revenue curve, I can see, has a positive slope up until this midpoint, at which point the slope is 0. That tells me that the maximum point on my total revenue curve is here, right, where the slope is 0. And before that, right, as I increase my quantity, my marginal revenue is positive, so my total revenue is increasing. An increase in quantity led to an increase in total revenue. And over here, we could kind of extrapolate this. Marginal revenue curve goes negative after that, right? The slope is negative, meaning that the total revenue is decreasing as quantity increases. So that's what's happening here in the picture for my linear demand curve. But that helps us actually understand something a little bit more generically about the relationship between elasticity and marginal revenue in general, because we can rewrite actually marginal revenue as a function of elasticity. So let's go back to not linear demand here, but let's go back to this generic way of writing marginal revenue. P plus Q times dP dQ. And we've almost got here elasticity, and we can see how it's a function of elasticity if we try to pull a P out. So I'm going to write P times 1 plus, now to pull a P out of here, there's no P, so I have to divide by P. So I get this, and this is something very similar to elasticity, but upside down, right? So elasticity was P over Q times dQ dP. This is the inverse of that. It's 1 over elasticity. So marginal revenue is price times 1 plus 1 over the price elasticity of demand. So what does that tell me? Well, it tells me that marginal revenue is related to price elasticity. And in fact, marginal revenue will always go to 0 at the unit elastic point. Now, the firm, I don't know exactly because I don't have cost here, but I know that the firm is never going to want to be producing on the inelastic portion of the demand curve. Why? Because, well, of course, as I produce a larger quantity, my costs go up. So I only want to continue producing as long as my marginal revenue is higher than my marginal cost, and marginal revenue goes to 0 at the unit elastic point, right? So I know if I'm producing more and my total revenue is going down, that's never going to be good, especially because it probably costs me something to produce this product. So the firm will never want to produce over here. The firm with market power will always operate on the elastic portion of the demand curve. And where along the elastic portion of the demand curve they will want to be operating depends, of course, on total cost, but also on elasticity. So we can here think about, if marginal revenue is equal to marginal cost, what is this relationship between price and elasticity? So if I use this formula here for marginal revenue, and I set that equal to marginal cost, I can rearrange this to think about the markup, price minus marginal cost over price is equal to 1 over elasticity. So this here, price minus marginal cost, is like the markup, because in a competitive industry, the price would be equal to marginal cost. So how much higher is the price than the marginal cost? It tells me the markup on that product. So here, this is the markup, how much the firm is able to raise price. And you can see that that's related to elasticity. In fact, it's inversely related to elasticity. So that for more elastic products, we're going to have, there should be a negative there, we're going to have a lower markup. For less elastic products, we're going to have a higher markup. And that makes sense. When I increase the price, the downside of that is that fewer people buy my product. That is less true for inelastic goods, right? So say you sell something that everybody needs to buy, you're going to be able to increase your price a lot more because people still will buy your product despite the price increases. And so as a firm with market power, your ability to raise your price depends on the price elasticity of your product. Now, remember that one of the big determinants of price elasticity is the availability of substitutes. And so in some sense here, we are trying to measure how competitive this market is, not in terms of, how many direct competitors you have necessarily, but in how easily people can substitute away from your product to purchase other products.